Using a Ufer ground or wire bus in the footer is a common practice for lightning arrestor systems in commercial and industrial applications. It provides a low resistance path to ground and can be used to connect multiple grounding points, including lightning rods and electrical service. Advantages of a Ufer ground are firstly, low resistance to ground. Secondly, it is easy to install and maintain. Thirdly, it can handle multiple grounding points. Fourthly, it is durable and long-lasting. Pole-top units that create a field over the structure are called lightning rods or air terminals. They are designed to attract lightning strikes and direct them to the ground through the grounding system. Advantages of lightning rods include firstly, protecting a larger area than point-and-rod systems. Secondly, they are less obtrusive than traditional lightning rods. Thirdly, they can be used on existing buildings. There is experience with pole-top units. They have been used successfully in various applications, including commercial buildings, industrial facilities, residential areas, and telecommunication towers. When installing a lightning arrestor system, several factors should be considered. Firstly, location. The system should be designed to protect the entire structure, including the roof, walls, and chimneys. Secondly, grounding. The grounding system should be low resistance and capable of handling the potential lightning current. Thirdly, maintenance. The system should be regularly inspected and maintained to ensure its effectiveness. Both the Ufer ground or wire bus and the footer and pole-top lightning rods can be effective methods for protecting against lightning strikes. The best option for your specific structure will depend on several factors, including the size, location, and desired level of protection. It is recommended to consult with a qualified electrician or lightning protection specialist to determine the most suitable system. A low-resistance ground is essential for effective lightning protection. The Ufer ground achieves this by encasing a conductor, typically a copper wire, within the concrete foundation of a structure. This creates a large contact area with the earth, significantly reducing ground resistance compared to traditional grounding rods. Proper installation is crucial for a Ufer ground to function correctly. The conductor must be fully encased in concrete and free from corrosion. Regular inspection and maintenance are necessary to ensure its continued effectiveness. Lightning rods, also known as air terminals, offer an alternative approach to lightning protection. These devices are strategically placed on a structure to intercept lightning strikes and safely channel the current to ground. Pole-top units are a type of lightning rod designed for mounting on poles or masts, extending their protective range. The effectiveness of lightning rods depends on their placement and the overall grounding system. Proper installation and maintenance are critical to ensure they function as intended. When considering a lightning protection system, evaluate the specific needs and characteristics of the structure. Factors such as building height, location, and surrounding terrain can influence the choice between a Ufer ground, lightning rods, or a combination of both. Consulting with a qualified expert is recommended to determine the most appropriate solution. Remember that a comprehensive lightning protection system includes not only grounding and air terminals but also surge protection devices to safeguard sensitive electrical equipment. These devices protect against voltage spikes that can occur during lightning events. Regular inspection and maintenance of all components are essential for maintaining the effectiveness of the lightning protection system. Ensure that all connections are secure and free from corrosion, and that grounding conductors are properly buried and protected. Consider the local climate and environmental conditions when designing and maintaining a lightning protection system. Areas with frequent lightning strikes or corrosive soils may require more robust grounding and protection measures. Stay informed about the latest standards and best practices for lightning protection. Building codes and industry guidelines are constantly evolving to reflect advancements in technology and safety. A qualified electrician or lightning protection specialist can provide guidance on compliance with applicable regulations. Lightning protection systems are designed to minimize the risk of damage and injury from lightning strikes, but they cannot guarantee absolute protection. Lightning is a powerful force of nature, and even the best designed systems can be overwhelmed in extreme events. However, by implementing a comprehensive lightning protection strategy, you can significantly reduce the potential for loss. In addition to protecting the structure itself, a lightning protection system can also help safeguard the occupants inside. By providing a safe path for lightning current to ground, the system minimizes the risk of electrical shock and fire. Consider the aesthetic impact of lightning protection components when planning the installation. While functionality is paramount, it is possible to integrate lightning rods and grounding conductors in a way that is visually appealing and minimizes their obtrusiveness. Explore different materials and finishes to complement the architectural style of the structure. Remember that a well-designed lightning protection system is an investment in safety and peace of mind. By taking proactive measures to protect against lightning strikes, you can reduce the risk of damage, injury, and financial loss. Consult with a qualified expert to assess your specific needs and develop a customized lightning protection solution. In areas with high lightning activity, consider installing a lightning detection system to provide early warning of approaching storms. These systems can alert occupants to take necessary precautions, such as seeking shelter indoors and disconnecting sensitive electronic equipment. A lightning protection system should be considered an integral part of the overall building design, rather than an afterthought. By incorporating lightning protection measures from the outset, you can ensure that they are properly integrated with the structure and that they meet all applicable codes and standards. Regular testing of the lightning protection system is essential to verify its effectiveness. A qualified electrician or lightning protection specialist can conduct tests to measure ground resistance, check the integrity of connections, and ensure that all components are functioning correctly. The results of these tests can be used to identify any areas that require maintenance or repair. Consider the environmental impact of the lightning protection system. Choose materials and installation methods that minimize disturbance to the surrounding ecosystem and that are sustainable over the long term. Avoid the use of hazardous chemicals or materials that could contaminate the soil or water. Remember that lightning protection is a shared responsibility. Educate occupants about the importance of lightning safety and encourage them to take appropriate precautions during thunderstorms. Provide clear instructions on what to do in the event of a lightning strike. By working together, we can create safer communities and reduce the risk of lightning-related incidents. A lightning protection system is not a substitute for common sense. Always follow basic safety guidelines during thunderstorms, such as seeking shelter indoors, avoiding contact with water, and staying away from electrical appliances. A comprehensive lightning protection strategy combines both passive and active measures. Passive measures include grounding and air terminals, while active measures include lightning detection and warning systems. By integrating both types of measures, you can create a more robust and effective lightning protection solution. Consider the long-term cost of ownership when evaluating different lightning protection systems. While some systems may have a lower initial cost, they may require more frequent maintenance or have a shorter lifespan. Choose a system that offers the best balance of performance, durability, and affordability. Remember that lightning protection is a continuous process. As technology advances and building codes evolve, it is important to stay informed and update your lightning protection system accordingly. Consult with a qualified expert to ensure that your system remains effective and compliant with all applicable regulations. A lightning protection system should be designed to protect not only the structure itself, but also the surrounding property and infrastructure. Consider the potential impact of a lightning strike on nearby trees, power lines, and other utilities. Implement measures to minimize the risk of damage and disruption. Remember that lightning protection is a team effort. Collaborate with architects, engineers, contractors, and other professionals to ensure that the lightning protection system is properly integrated with the overall building design and construction. A well-coordinated approach is essential for achieving optimal results. A lightning protection system is an investment in the future. By protecting your property from lightning strikes, you can preserve its value and ensure its long-term sustainability. Consult with a qualified expert to develop a lightning protection plan that meets your specific needs and budget. A lightning protection system is a critical component of any comprehensive safety plan. By taking proactive measures to protect against lightning strikes, you can create a safer environment for yourself, your family, and your community.